Our next speaker is an author at Pluralsight and a senior web engineer at Expedia, who is here to tell us about NoSide JavaScript. Everybody give it up for Ryan Lewis.
Okay. Hi, everybody. I'm Ryan H. Lewis. The H is in there to differentiate me from the other Ryan Lewis from Seattle. It's very unfortunate. I had most of my life without that. So today I'm here to talk to you about NoSide JavaScript and the serverless revolution. And basically, NoSide JavaScript is a new type of JavaScript that runs on serverless. I've been doing it for about a year and a half, and I felt that it is different enough from server-side and client-side JavaScript to kind of give it its own name. So a little bit about me. Like Ken said, I'm a senior engineer at Expedia. I've been doing serverless for about a year and a half. Also an instructor at Pluralsight. I do instructional courses on JavaScript and AWS. And then I'm also the executive thing doer at Meetcube, founder, whatever you would call it. It's a record label that I run that's been releasing Japanese hardcore and punk music for about the past 15 years. So that's me. And so before we get started, I want to tell you a story. This is kind of a fable and alternate history. Names were changed to avoid incriminating people. So imagine this in that movie guy who does the trailers and he's got the really deep voice. I can't do that, so just imagine it in that voice. The year is 2017, planet Earth. Fulfilling Atwood's law, JavaScript engineers rule the world, solving every problem with closures. Two factions fight for control over the sacred text, ECMA 262. Each with their own interpretation of the Holy Script, argue over amendments to each annual edition. The client-side JavaScripters, devotees to browser culture, even they are divided into further subcultures, Angularians, jQueryals, and Reactites, to name a few. And the server-side JavaScripters, event loop process worshipers who share code through an interconnected cyber repository called the Neo Particle Modulator. Both sides reside in the hugely popular cloud stacks, oversized high-rises central to the web. For years, the two groups struggled for dominance in the cloud stacks. But now, a new paradigm has unseated both for the true CEO position, serverless, an interconnected operations team destroying overlord that makes virtual server management a thing of the past. None of the JavaScripters could withstand the overwhelming presence of serverless. The lack of servers brought down the server-side JavaScripters as they ran into the dreaded serverless limits. The client-side JavaScripters lasted longer, but eventually succumbed to the complexity of the build scripts they used to navigate the serverless labyrinth. Therefore, a new type of JavaScripter has emerged that runs circles around serverless. They understand the limits of serverless and have developed patterns to navigate even the most complex serverless requirements. These are the NoSide JavaScripters, who look down at the cloud stacks as they ascend to a distributed cloud nirvana. So, when we get back to the real talk, I want to start and talk about the serverless revolution because NoSide JavaScript won't make much sense unless you kind of get what serverless is. So we'll start back in time. First, there was the concept of on-premises servers, where you own the hardware, you're responsible for connecting it to the web, keeping it cool. If a server goes out of maintenance, you've got to replace it. You're basically physically managing these servers. And this is all, we're talking about web applications here. This is how you kind of deliver your application to the client. On-premises is still very much out there, but the cloud has started to take a lot of its market share. And the cloud was nice because you didn't have to deal with the physical management of these servers anymore. There are a lot of abstractions over it so that you were able to kind of virtualize this hardware and you could use it as you needed to. You weren't responsible for if the physical server died or if it needed to be upgraded or things like that. But you still had to own the server application management. So if you're running a process, you've got your application running on your server. If it dies and the server stops responding, that's your responsibility to get that going again. And so now we come to serverless. And in a lot of ways, I kind of think of this as the final evolution in this kind of web application delivery method. And serverless is really nice because you don't have to manage even the application cycle anymore. You've got near zero infrastructure configuration. You're able to just run your code. You give it to the platform, and it runs it for you. It manages a lot of things that you used to have to manage yourself when you were doing pure cloud type things. And the other nice thing is you only pay for what you use. So if your little bit of code only runs for a few 100 milliseconds, that's all you have to pay for. You don't have to pay for an idling server. So you can see that there's a lot of bonuses to this serverless cycle. So let's look at kind of how this works. And this is light on details, and I'm probably getting some things wrong, so apologies. But you've got your cloud provider, and an event comes in. This could be something like a HTTP request, or it could be a change in a database or a change to a file. There's lots of different types of events, and cloud providers differ on what types of events they offer you to listen to. When the event comes in, the cloud provider takes your function code, which was sitting somewhere, and it kind of hydrates it. It gets it ready to respond to that request. And there is a little bit of latency involved in this in terms of getting your code running, but it's very small. It's in the double to small triple digit millisecond range. And so your function does something in response to that event. It might respond to it. It might do something else along the line. And your cloud provider leaves your function up and lets it stay warm, as kind of what they call it, for a while. And then after some sort of timeout, it will take it down. But if a new event comes in, well, then you don't have that latency for getting your code up and running. Finally, once your events are done and that period comes down, then the cloud provider will take away your function and it'll be done. So that's kind of how serverless works. And so one thing I hope to communicate to you is that it's simple. It auto-scales for you. You don't have to restart instances. It really just runs your code, and you're able to get started with it really quickly. I've also found that serverless is really empowering. So like I said, we've been doing it in Expedia for about a year. And one thing I found is that a lot of the developers who are working, now it's no longer one of the things where you build your code and you throw it over the fence and the operations team puts it out on a server somewhere. You're actually able to get your code running within seconds of making a change. And there's a lot of more, I guess, license that I feel like the developers feel. So it's really cool and empowers developers much more than anything before. And this is kind of the transition to the next part. It's event-driven. So events happen. Like I said, they could be HTTP requests. They could be other types of events. And your code runs in response to those events. And if you know anything about JavaScript, which I'm assuming you do, considering the conference we're at, JavaScript is also very event-driven. And so because of that, I feel like serverless is really perfect for JavaScript, and JavaScript is perfect for serverless. And what I've felt as I've been doing a lot of JavaScript on serverless for the past year and a half is that there's a really nice harmony between the way that you build your application and the way that you think about your application, and then the underlying architecture kind of mirroring that. So I feel like there's a really nice synergy between serverless and JavaScript together. And there's certain things that I think make those really nice to work with. And so I felt like there's enough difference that we can call it something new. And so I thought NoSide JavaScript was a cool, radical sounding name. Since serverless, there's no servers, even though there are servers. So that's where NoSide JavaScript comes from. So what I tried to do is I tried to think about all the things when I'm working in NoSide JavaScript, what's different? It is on serverless, it is running on the Node platform, so that's the same. You're going to have the same API. But there are some quirks to serverless, and there are some ways to think about things when you're building applications. That's a little bit different from if you were building a normal, like, Express web server or something like that. So boiled them down into some principles, and now we're going to go through a list. So principle 1, forget what you know. So you may have been doing JavaScript for a while. especially if you're a node engineer, there's some significant differences between how you're going to build an application in serverless and how you're going to build it in Node. First of all, there's no HTTP server. You're purely building functions, and so those functions respond to events. You're not going to have to be listening to a port or anything like that. You'll have a service that will handle listening to those ports and sending those events down to you. So no HTTP server. You don't want long-running processes. Again, this is a pay-for-what-you-use type thing. So you want to be very smart about how long your functions run. In addition, there are limits to the amount of time your function can run, like John mentioned in a couple talks ago. So you definitely want to keep an eye on these processes that may run long. And then there's no process management, because serverless takes care of the scaling for you. You don't have to worry about creating multiple node processes and managing those and making sure they stay alive and things like that. So you're, in a lot of ways, I feel like you're freed up to think more about the code and less about kind of the architecture pieces that you may have to put in your code. Principle 2, one function, one purpose. So I'm a big fan of the single responsibility principle, which basically says kind of something like one unit of code should do one thing and not have a ton of side effects. I know I just butchered that, but so when I think about serverless applications and how I'm going to build things, I like to try to follow the single responsibility principle and make sure that each function that I write has one main purpose. And if it gets too big, then I try to break it up. So the first part of this is please don't build a monolith. I've seen people build monolith applications on serverless. They take their Java application, which was running on the server, and they stick it on an AWS Lambda, and it's just a horrible thing to witness. So definitely don't build a monolith. And try to follow single responsibility principle whenever you can when you're building these functions. And finally, you can track invocation time. You can look at how long your function has been running, and that can give you a good idea when you might want to think about breaking up that function into multiple functions. It's a good kind of way to measure them. Principle 3, think distributed. So again, when you're thinking about, when you're working with NoSide JavaScript and you're thinking about building an application, you're no longer thinking about a single kind of stack. You're no longer thinking about a single node process. You need to worry about, or you need to consider how you're going to interact with all the different services that you have access to. And they're definitely your friends. With AWS as an example, there are services for getting a REST API gets set up. There are services for caches, file systems, databases, things like that. And these are definitely going to be your best friends when you're working in NoSide JavaScript. And also, don't be afraid to put the fun back in function. The more functions you have, the better. It's not a bad thing to have plenty of functions. I would say on a small to mid-sized serverless application, you may have at least 20 serverless functions going on. So it's not a bad thing. But you definitely want to keep it practical. I've seen some people go far off into the outfield with these types of things, and they try to use every single service available to them in a cloud provider, and it ends up looking really messy and being horrible to maintain. Principle 4, read but don't write. So this is kind of a gotcha that I realized, and it's a very interesting thing. It makes sense when you think about it, but it's kind of weird when you encounter it. On serverless, you have a read-only file system. So when you are running your code, you can't write anything to that file system, which is kind of something that you may be very, very used to. So your serverless function is going to be completely stateless. So you're not going to be able to rely on any type of internal state. Instead, you're going to want to use some type of cache service or a database to take care of your application state or changes. And then you're going to want to make use of static storage like in AWS S3 if you do need to store some sort of file. Definitely use a CDN. Don't serve files up from your serverless function. That's not a great thing to do. Principle 5, know your limits. So when you're working in NoSide JavaScript and really kind of the serverless platform as a whole, you do have limits that are a little bit unique to it. So you do need to be aware of a couple things. One, there is a limit to the amount of, to the size of the package that you can upload for your serverless function. So on AWS, for instance, it's 50 megabytes. You may think you'll never hit that because that seems like a lot, but I know we've hit that multiple times, and we've had to be very particular about which dependencies we were going to be downloading and including, because the upload includes all of your dependencies and everything else. When that's expanded, the function size has to be less than 250 megabytes. So it's a limit that you may have never had to really care about, like how big is your application, especially when you're doing node things. So this is a limit to be aware of. And then you also have a limit on concurrent invocations. So again, with AWS, you can have 1,000 running concurrent Lambdas. And you may think you may never hit this because 1,000 seems like a lot. But you have to keep in mind you don't just have one function. You have 20-plus functions. And some companies actually have a single account for their entire company, which means there's multiple teams, which means that pretty soon those 1,000 concurrent invocations doesn't seem like that's so far away. And you have to start considering how you're building your kind of serverless as a whole. And this limit can be raised. AWS lets you raise it past 1,000, but it's definitely there to start with. And then finally, you have timeouts and you have resource limits. And the timeout limits is when you set up your Lambda, you're able to say, I want my function to run for 3 seconds. And at the end of 3 seconds, it will cease execution of that. Even if there's some asynchronous request that it's waiting on, it will stop executing and it'll return some sort of error to the requester. And so there's a timeout limit, and you just want to be aware of that. You can raise it past 3 seconds. That's just what it's set up as by default. And then there's also resource limits for memory, and the memory resource limit actually has a direct correlation to the number of CPUs that your code's going to be running on. So these are just some things to be aware of when you're doing NoSide JavaScript that a little bit different than Node. And then principle 6, static version. So one of the nice things about serverless is you have a very stable build target. You are going to be stuck on a version of Node that the cloud provider has decided is great. So far with AWS, they've been keeping to the LTS branches, so you can pick between 4x and 6x. So it's nice because one thing that I've found is that I've been able to go really deep on the particulars of a certain version of Node, which is something that really before I was just kind of keeping up with whatever was current. But the downside is that it's not bleeding edge. So I really felt this when AWS Lambda was still stuck on version 4, and version 6 of Node had come out, and I really wanted to use all those cool ES6 features, but I wasn't able to. That was very painful. And then it's slow to update. So this is kind of a con of the whole static versioning thing. And one thing that I found that was particularly, I guess you could say, alarming is with a couple of months ago, Node had a big security release, and they were telling everybody to upgrade. It's very important. Some sort of bug found in the HTTP module, and there was kind of a big PR push for that. Well, AWS Lambdas, as of yesterday, I just checked it again, are still stuck on 6.10.3, which is vulnerable to that bug. So it's definitely something to consider that you're going to be stuck on a version of Node, which has its good things and its bad things. For more detail on that, Google Cloud Platform has updated. So I don't know, AWS is just late to the party or something. I'm not sure. All right. And so this is kind of principle number 7, but I gave it its own section because I feel like it's so important. And I'm going to possibly introduce you to the serverless framework, which is a little bit different from serverless as a concept. But there's a couple things when you're working in serverless and NoSide JavaScript that you care about. First of all is local development. So if you were just starting out from scratch, you'd write your code locally, and then you would upload it to the cloud, and you would see that Lambda execute and see whether it worked or not. And then you did a typo, and then you have to push it up again, and it's a little bit painful. Local development is something that is needed to be nice. You also have deployment concerns. So if you have a single Lambda, let's say you're working locally and you have a single Lambda, and again you do that typo, it's not too bad to deploy it out to the cloud yourself. But let's say you have 20 Lambdas and that typo affects all of them. Well, then you have to deploy out 20 Lambdas at once, which if you're doing it manually is not a small task. And then finally, you may be dealing with some resources in your cloud provider, those services that I talked about that you may be using. And you want to be able to create those easily and make sure that if you need to tear them down or make a significant change, there's a very simple way to do that, and that you can also recreate it in multiple different accounts or regions or things like that. And so for all of these things, the serverless framework is actually the answer. All three of those bullet points, it lets you develop locally and test locally. It deploys everything out for you. It creates your resources. It's really great. You run everything from a configuration file where you tell it, hey, this is my function, these are the names, and this is the code that I want you to run when that function is invoked. And that configuration file kind of owns everything about your serverless service. It also has a really nice CLI, kind of like every tool these days has to have a cool CLI. Well, serverless has a cool one with autocomplete, and it allows you to really simply do all of these things from your local computer. And then it has a robust plugin architecture. So you're able, it reminded me a lot of Webpack in that you're able to extend it and you're able to kind of plug into the life cycle and have it do particular things. I published a few plugins out there, and then we've also built some internally, and I can say it's extremely easy to use. So here's kind of an image of what serverless does. You've got your serverless configuration file, and you've got your code. You've built these locally, and you push that into serverless. And serverless does all this stuff for you, and you don't even know what's happening, and then all of a sudden it says it's ready, and it gives you a fancy link, and then you're able to go out and see your serverless function running in the cloud, and it's really awesome. It does the deployment, it does the resource creation. If you have a change in a resource, like let's say you want to change the name of this Dynamo table for your database, it will handle all of the change and everything like that. In a lot of ways, if you do go into this stuff and start using the serverless framework, I almost wish you would not use serverless and try to do all this manually first, just so you could really appreciate everything it does for you. Because for probably about the first 3 or 4 months we were working in serverless, I had no clue the serverless framework was out there. And when I did, I guess that's one of the reasons I like it so much, is because I really know everything that it's doing, and it's really horrible, all the things that it is that I'm not having to do anymore. Serverless is cross-provider, so you don't have to use AWS. It does support AWS. It also supports Azure, Google Cloud Platform. I didn't want to go to 4 bullets for this slide, so it also supports IBM's Bluemix. So there's not really any reason not to use serverless for the serverless framework for your serverless architecture on any of these providers. And just an image of kind of what it looks like to get started. So you install serverless globally with npm i-g serverless. That installs the serverless CLI. Then with the serverless CLI, you can type serverless create -- template AWS Node.js. And these templates are basically boilerplate that combine a language and a provider. So in this case, I'm using Node.js on AWS Lambda, but you don't actually have to do Node when you're using the serverless framework. You can use it for Java or Python or whatever other language your serverless functions are written in. And then you type serverless deploy, and then all the magic happens. And it does all the deployment, it does all the resource creation, it packages all of your stuff together, and it takes that configuration file to figure out what it's supposed to be doing. So it's really simple, and I would say that with with 3 commands, it's really nice to be able to go from I've never done serverless before to I have a Lambda out there running in the cloud and I don't know what to do with it. So it's awesome. I hope you try it out. Some related links. The serverless framework you can find at serverless.com. And it has all information there on how to get things set up and get things going. I'm still working on this website, so there's just a piece of text on it, but I'm going to kind of try to start collecting things and collect a lot of resources on how to do NoSide JavaScript at NoSideJS.com, so you can check that out as well. I got some stickers made with the little NoSide JavaScript logo, and I've got a bunch of them, so please, I'm going to stand over in that corner. Please come grab one from me. And I also have a YouTube channel where I do videos on serverless and AWS and JavaScript things, so you can check me out there. That's it. Thank you.